Good day. Once again, we are going to be dealing with topic 1. In the next section, as we had done previously, topic 1 is on numbers, but now we go and deal with the concept of surds. Surds is a very, very important section in the examinations. You will encounter surds, but this time for approximately 6, 7, or even 8 marks. The concept of surds needs to be understood in detail. While we are dealing with surds, the first thing that we will have to understand is, what is a surd? In order to understand a surd, let's look at the square roots of certain numbers. For instance, the square root of 25. Now this is something familiar to you, the square root of 25. The square root of 25, as we all know, is equal to 5. Most of you will know it could be positive or it could be negative, but that is not what I'm concentrating on at the moment. All I'm looking at is the square root of 25 is equal to 5. And obviously we could get the square root of other numbers. For example, the square root of 9 over 4. The square root of 9 divided by 4 is equivalent to the square root of 9 divided by the square root of 4. In this case, the square root of 9 over 4 is equal to 3 divided by 2. These square roots that I have dealt with over here can be written as whole numbers, or it could be written as fractions. In other words, both these can be written as rational numbers. What about the square root of 3? Or for that matter, the square root of 2? These, or the roots to these, are not whole numbers or fractions. So basically we can say they have irrational values. We cannot find the square root of 3 as being a whole number. Neither can we get the square root of 2 as being a whole number. So therefore we call them irrational, or they have irrational values. When we have square roots which gives irrational values, we call them surds. When we have square roots which gives irrational values, we call them surds. Examples of surds, as we are done here: root 2, root 3, also root 5, the square root of 7. All of these are examples of surds. Now there are many more examples. As we go along, you will look and find more examples of surds. Automatically you will notice that root 2, root 3, root 5, root 7, the answers cannot be whole numbers. For the purpose of the examinations, we are now going to go on to simplification of surds. The basic exponents will help us to simplify surds. Now, you have not come to the section on exponents, but remember, we are talking about the basic exponents. I have provided you a list of many exponents. We will not be using all of them, but I'll highlight the areas where we are looking at. For example, 2 squared. 2 squared is equal to 4. Or automatically I can say the square root of 4 is equal to 2. Now 2 squared is equal to 4. If I go further, these I will not be interested in, but you will come across them as you deal with your mathematics. 2 to the exponent 4, and so on. But I am simply concentrating on 2 squared. 2 squared is equal to 4. If I go further, 3 squared. 3 squared is equal to 9. Likewise, the square root of 9 is equal to 3. 3 cubed, 3 to the 4, I'm not interested in at the moment. 4 squared is equal to 16. 5 squared. 5 squared is equal to 25. On the same principle, I can go ahead and say the square root of 25 is equal to 5. Now you will see later why these numbers are important to me. And I can go on. 6 squared, 7 squared is equal to 49. 8 squared is equal to 64. 9 squared is equal to 81. Or the square root of 81 is equal to 9. And 10 squared is equal to 100. So if I go back to the ones that I'm going to be using, it will be each and every exponent where the power is 2. 2 squared, 3 squared, 4 squared, 5, 6, 7, 8, 9, and 10 squared. You will have a look and see how I'm going to be using this. Now please, you need to remember what I've illustrated in this part here. Some square roots can be broken down into a mixture of integer values and surds. Integer values. You came across this term when we were dealing with recurring decimals. Integers, yes, are whole numbers. So we are saying square roots can be broken up into integer values and surds. Whole numbers and surds will be the square root of a number that will not give you a whole answer. The following examples will illustrate this idea. To simplify the square root of 12. Now consider this, don't read on. The square root of 12. If I want to simplify the square root of 12, I need to be able to split up this 12 into factors. What are factors? Factors are numbers when multiplied together will give me this 12. For example, 12 times 1 is 12. 6 times 2 is 12. 4 times 3 is 12. I come across all these variations. Which one do I choose? I go back. I have to have a mixture of integer values and surds. If I deal with the square root of 12, the square root of 12 can be broken up into factors, but at least one of the factors that I use must have an exact square root. It must have an exact square root, meaning I must use the numbers 4 because I can get the square root of 4, 9 I can get the square root of 9, 16 I can get the square root of 16, but I need to ensure that my factors gives me 12, or basically I find the factors of 12. In this example, the square root of 12 is equal to the square root of 4 times 3. You will notice the 4 times 3 is the same as the 12. Why did I choose the 4 times 3? Because if I split them up, this becomes the square root of 4, which I can find the square root of, multiplied by the square root of 3. Now watch how I split this up. The square root of 4 times 3 is the same as the square root of 4 multiplied by the square root of 3. This is one of the surd rules which I'm going to illustrate or highlight a bit later on. For now, all I have done is I have split up the surd. I now go and find out if I can use or simplify it any further. This square root of 4 gives me an answer which is 2. The square root of 3 does not give me a whole answer, so I simply leave it as 2 root 3. The 2 comes from the square root of 4. The root 3 I simply take along because I cannot simplify that any further. Guys, the square root of 4 is equal to that 2 there. Now let's go a bit further. Trying another example. What about the square root of 20? The square root of 20, if I have to simplify, needs to be broken down into the factors of 20, where one of those factors I must be able to find the square root of. 20 is 20 multiplied by 1. It's not going to help me. 20 is 10 times 2. Not going to help me. But 20 can also equal to the square root of 4 times 5, where 4 times 5 is equal to 20. One more time. I had many choices. Why did I choose 4 times 5? The reason being, if I have to split this up, it becomes the square root of 4 multiplied by the square root of 5. And the square root of 4. The square root of 4 is equal to 2. The square root of 5 I leave as that, so my answer becomes 2 root 5. Ultimately, I can say the square root of 20 is the same as 2 root 5. Now, in a full-blown example, it is not necessary that you show each and every step. You can go from root 20 to 4 root 5 directly to the answer. That will suffice. I am just showing you every single step so you can understand how to deal with surds. Let's go further. I'm liking this. How about a few more examples, guys? The square root of 27. If I have to look at the square root of 27, I have here the number 27. I need to break up this 27. 27 times 1, yes. What about 9 times 3? I would opt for 9 times 3. 9 times 3. If I have to split this up, I get it as equal to the square root of 9 multiplied by the square root of 3. So it's the square root of 9 multiplied by the square root of 3. The square root of 9, yes, is 3. So the final answer here is 3 root 3. One more time, the square root of 9 is equal to 3. That's where I got that 3 from. Going further, the square root of 108. It's quite a large number. Now, as you go and deal with more examples, you will notice that you will be able to quickly resolve 108 into its factors. Because when it comes to the concept of surds, as you progress with the examples, it becomes a bit monotonous in terms of the actual values that they use. But as long as you get it right, that's all you should be concentrating on. 108 is equal to the square root of something times something. 108. 36 times 3. That's 36, 72, 108. Yes, is going to be the square root of 36 times 3. And if I have to split this up, I get the square root of 36 multiplied by, yes, the square root of 3. And the square root of 36 is equal to 6. So the answer is 6 root 3. One more time, guys. The square root of 108 is equal to 6 root 3. And that was a very nice example. To go further, the square root of 75. Now you're going to ponder over the number 75 and consider and say 75 is the square root of something multiplied by something else, but one of the numbers I must be able to find the square root of. Come on, guys, think. What do you think it'll be? Let's go. It can't be 4. 9. No. 25. It can never be 16, so 25. 25 times 3. This becomes the square root of 25 times 3. And the square root of 25 times 3 is the same as the square root of 25 multiplied by the square root of 3. Now, if I'm dealing with 25 times 3, this is going to equal to the square root of 25 multiplied by the square root of 3. Thank you, guys. And if I have to do this, the square root of 25. Square root of 25, yes, is 5. And the answer here becomes 5 root 3. Very good, guys. The square root of 25 is 5. So the answer becomes 5 root 3. Now, I want you to try an activity. Guys, try this activity. It'll do you some good. That's not the activity. Let's go further. Activity 1, surds. Simplify the following. Example number 3, example number 4, example number 5, Example number 6, 7, 8, 9, and 10. Anybody wondering what is that above my shoulder? That seems to be a bird. Guys, I want you to try these few examples. I'll give you but a few seconds to copy them down, and we will try them out. Right, while we have those examples, I would want you to do this, guys. You need to press pause. Do this activity first. Once you've completed this activity, then we can go ahead and look at the answers. Okay, guys, let's go to the answers. The square root of 20. If you have to look at the square root of 20 and try to break it down. Now, guys, you have already worked this out, but work with me. The square root of 20 is equal to, yes, the square root of 4 times 5. The square root of 4 multiplied by the square root of 5. Remember, if I want to break it up, the square root of 4 is equal to 2. The square root of 5, I cannot do anything else with it. It remains as the square root of 5. Going to example number 2, root 32. If I have to break up root 32, guys, yes, you should be getting the square root of 16 times 2, because 16 times 2 is equal to 32. And that, dear learners, the square root of 16 is equal to 4. Very good. Hopefully you got both right. Let's go to number 3, the square root of 8. Square root of 8 is 4 times 2, which is equal to 8. And the square root of 4 is equal to 2. So the square root of 4 is 2. The square root of 2, it remains as the square root of 2. Example number 4 is the square root of 80. Another big number, but it's a number that I want you to become accustomed to using. The square root of 80, if you did not get this, square root of 80 is the same as 16 multiplied by 5. Now, why did I use 16? It's because I can find the square root of 16. And the square root of 16 is 4, so your answer becomes 4 root 5. 125, the square root of 125, you should be getting, this is totally wrong, guys. It's not 16 times 5. The square root of 125. Let's rework this one here out. There seems to be a slight hassle with this one. This here we are saying is incorrect. The square root of 125 is actually 25 multiplied by 5, which is equal to the square root of 25, guys, gives you an answer of 5, and it becomes 5 root 5. So in terms of the work that we had there, we had an error in the question. Remember, 125 is 25 times 5, which is equal to 5 root 5. Thank you, guys. So that is a total incorrect answer in terms of that. Number 6, the square root of 40. If I'm dealing with the square root of 40, again, 40 is equal to 4 times 10 is equal to 40. I work with the square root of 4. The square root of 4 is equal to 2, so the answer here is 2 root 10. Thank you. Number 7 is square root of 12, something that we have done previously. Not a problem at all. The square root of 12, yes. The square root of 4 times 3, and the square root of 4 is equal to 2. So the answer here becomes 2 root 3. Thank you. At least that one is correct. We are not making mistakes from our side. Guys, how are we going? 7 out of 7. Let's go for 8 out of 8. The square root of 96. The square root of 96 is the square root of 16 times 6. Initially, it will take you some time to get used to these numbers, but as I mentioned before, after a while, you simply know. Square root of 96 is the same as the square root of 16 multiplied by 6. And the square root of 16 is 4. So the answer here becomes 4 root 6. Number 9, square root of 45. This is easy, guys. Is the same as the square root of 9 times 5. Square root of 9 is 3. So the answer here becomes 3 root 5. How's it? 9 out of 9. Let's go for the full 10. Square root of 54 is the same as the square root of 9 times 6. The square root of 9 I know is 3, so my answer should be 3 root 6. Okay, guys, 10 out of 10. Any less is not good enough. You need to be able to get full marks. In the examinations, you may be getting all the others right, but if it's all included in one example and you make an error somewhere along the line, valuable marks are being lost. Now let's go on to a little proof. This is the proof that I promised you a bit early on. Now nonetheless, I want to show this to you even though you have been using it all along. The rule says the nth root of a multiplied by the nth root of b is equal to the nth root of a times b. Now this is exactly what I have been doing, but in reverse. I have been taking ab and expanding it to the left hand side here. But let's go ahead and just have a simple proof to see that this one really works. Simple example. Let's consider this. If I ask you what is the square root of 16 multiplied by the square root of 4? And I'm saying according to my rule, this is the same as the square root of 16 times 4. Now if this balances off, it means that this rule actually works. Let's double check. The square root of 16 is 4. The square root of 4 is equal to 2. And 4 times 2 we know is equal to 8. 16 times 4 is 64. The square root of 64. 4 times 2 is equal to 8, and the square root of 64 is equal to 8. Which means, guys, my rule on the top here really works. Now let's double check further rules. How about something like this? The nth root of a divided by the nth root of b. Now we are saying that's equivalent to the nth root of a divided by b. Again, I'm going to use this very, very simple example to show this point. It goes ahead and tells me, if I want to use a simple example of the square root of 64 divided by the square root of 16. There's the square root of 64 divided by the square root of 16. My rule tells me it's the same as the square root of 64 divided by 16. That's what my rule is telling me. Let's double check. What's the square root of 64, guys? 8. What's the square root of 16? 4. So I have here 8 over 4. 64 divided by 16 is equal to 4. I've got you. What is the square root of 4 and 8 over 4? It's the same thing. 8 over 4 is equal to 2. The square root of 4 is equal to 2. So ultimately, the rule that I'm using on the top here, again, is correct. Now at level 2, I might not be using this rule as it stands very, very often. But as long as I understand the rule, it is going to assist me. What about a rule like this? The square root or the p root of the q root of a. A bit of a mouthful that. Is the same as p times q root a. Again, a simple example. What if I have to ask you, I don't know why this is keep coming up, guys, but forgive me for that. If we have to go to a scenario like this, and it tells me what's the square root of the square root of 16? According to our rule, 2 times 2 is 4, so it's the same as the fourth root of 16. And the fourth root of 16 is equal to 2. What about this? The square root of 16 is 4. So I'm left with the square root of 4, and the square root of 4 is equal to 2. So I have 2, which is equal to 2. Now guys, These three rules, I want you to keep going back and forth until you get an idea of what I'm trying to speak about here. But at the same time, these are not the rules that we fully need to utilize in order to understand surds, because logic will prevail in terms of what you need to do when you are reducing or expanding a surd. I want you to consider the following examples. Simplify the following. Hey, there's it. Seems long. It says root 3 plus root 5 plus root 3 minus root 5. Now if I have something similar to this, it says root 3 plus root 5 plus root 3 minus root 5. How do I go about understanding this better? Now let's say that root 3 is an apple and root 5 is a banana. So ultimately I have an apple plus a banana plus another apple minus a banana. The banana and the banana will cancel off. Basically tells me that I'm left now with 2 apples. And remember, the apple was the same as root 3, so the answer here becomes 2 root 3. I hope you understand that concept. It's a very, very important concept that is going to assist us when we are simplifying our surds. Let's go to example number 2. In example number 2, we have the square root of 32 plus the square root of 98 minus the square root of 18. Seems a bit complicated, but guys, this is what you should be expecting in the examinations. A bit easy for an examination, but nonetheless expect an example like this. It goes on to say, root 32. If I have to simplify this surd, root 32 is the same as me saying the square root of 16 times 2. 16 times 2 is equal to 32. I'm just going to highlight that one, so you know it's equivalent to what I have down here. Then I go here plus the square root of 98. And the square root of 98 is the same as the square root of 49 times 2. Now once I've got the square root of 49 times 2, I go to the last one, which is minus the square root of 18. And that becomes 18. Yes, it's the same as the square root of 9 times 2. If I want to simplify this, guys, I go to the next step. The square root of 16 times 2 is the same as the square root of 16 times the square root of 2. Is that fine? The square root of 49 times 2 is the same as the square root of 49 times the square root of 2. And the last one here is the square root of 9 times 2 is the same as the square root of 9 times the square root of 2. Now all I have done was I expanded, but as you get used to these examples, guys, you don't even have to worry about showing so many steps. Going further, the square root of 16 is 4, and that becomes 4 root 2. This, let's go to another color. Look at this, guys. If I have to deal with this, the square root of 49 times 2. It's the same as the square root of 49, which is 7 root 2. Minus, this becomes the square root of 9, which is 3 root 2. And obviously now, guys, I've got here 4 apples plus 7 apples minus 3 apples is equal to 8 apples. Or in this case, it is equal to 8 root 2. Now a simple example, a lot of work involved, but obviously you do not have to show each and every step. Get accustomed to it and then start skipping your steps. Activity 2, simplification of surds. Simplify the following for me, guys. Once again, a simple example. Number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, and number 10. You've got these 10 examples. While you're doing the 10 examples, let me teach you how to count in another language. एक, दो, तीन, चार, पाँच, छः, सात, आठ, नौ, 10. 10 is 10. These are your 10 examples, guys. Please remember, as you are copying the examples, copy them down. Ensure that you try these examples first before going into the answer section. I'm going to leave the screen on for a few more seconds. If you need more time, use the pause button. I think I got rid of that sign for long now. Right. Okay, guys, let's go to the next one. Simplification of surds. The answers. That's what we like, the answers. Double check your answers with the answers that I have. This is easy. 5 apples plus 7 apples minus 2 apples. That's 12 minus 2, which is equal to 10 apples. Very good. In this example, this 12 is fine. Alright, I think I made a mistake in the example there. It's supposed to be the square root of 12. Guys, if it wasn't in the previous example, just put it down as the square root of 12. Alright, so in this example here, I had to include the square root in terms of up here. Let's go down here, square root of 12. And the square root of 12 is equal to the square root of 4 times 3 minus 5 root 3. The square root of 4 is equal to 2 root 3 minus 5 root 3, and yes, the answer becomes minus 3 root 3. Please amend this if the question was wrong. If the question was wrong, you get full credit for it. Example number 3. In example number 3, 3 root 7 plus 4 root 7, very good, 7 root 7. Example number 4, 3 root 2. This is the portion that we need to simply sort out. Hey, how about that? Yellow and purple makes red. Did anybody know that? I didn't. That becomes 3 root 2 plus 4 root 2. Yeah, I like to make this. Let's make this red again. Fantastic. Alright, 3 root 2 plus 4 root 2. Remember, this is the square root of 4, which is equal to 2 root 2. 3 root 2 plus 2 root 2 is equal to 5 root 2. Guys, how are we going? Hopefully we are getting it correct. Example number 5, a bit more difficult. Square root of 45, square root of 20, and the square root of 80. Let's highlight it. Square root of 45 is equal to the square root of 9 times 5. Guys, are we okay with that? The square root of 20 is equal to 4 root 5. Are we happy with that? Let's go to something else. The square root of 80 is the same as the square root of 16 times 5. And if I go further, that's 3 root 5, 2 root 5, 4 root 5. And the answer here becomes 3 plus 2 is 5, minus 4 becomes 1 root 5, which I simply can leave as the square root of 5. Example number 6. In example number 6, 5 root 2 minus the square root of 32 plus root 8. This is alright. 32 works out to being the square root of 16 times 2. And if I go further, the square root of 8 is the same as the square root of 4 times 2. 5 root 2 remains the same. The square root of 16 is 4 root 2. The square root of 4 times 2 is equal to 2 root 2. 5 minus 4 plus 2 is equal to 3 root 2. Correct. Example number 7. And this one I will not explain too much. Your second step. Please tick off as you go along. And your final answer. Very good. And number 8. 200. 200 is a very, very large number. Guys, red on red, what do you think that will give me? More red. Correct. Alright. If we have to look in terms of this question here, we are going on to say the square root of 200 is the same as the square root of 100 times 2. 72 is the same as 36 times 2. 98 is the same as 49 times 2. That's 10 root 2, 6 root 2, 7 root 2, and your final answer is 11 root 2. Thank you very much. Let's go on now to number 9. Number 9 is very, very similar to all the other examples that we have been dealing with, and the answer that you should end up with is 4 root 3. Last but not least, question number 10. And guys, your answer for question number 10, minus 3 root 2. How about that, Jack? Are we fine with that, guys? If not, speak to me. I might not be able to hear you, but you can try. I'm going to pause for a moment. If there's any alterations or corrections that you need to make, go ahead and make it. If that's not enough time, use the screen and press pause. Use the icon for pause and pause. Guys, further examples involving surds. Now these are the classic examination type questions. I want you to concentrate on them. Might not go too fast, but I'm not going to go too slow either. Starting off with a simple example. 6 times root 80 plus 2 root 20 minus square root of 125. This is equal to 6 root 80. Which is the same as 6. Don't worry about this. I'm simply bringing that 6 down. You see that 6 has nothing to do with my simplification as yet. 80 is the same as 16 times 5. Guys, can you see where I got that from? It's the same as 16 times 5. Let's go with the next one. 2 times the square root of 20. 2 times the square root of 20. The 2 remains, but the square root of 20 is the same as 4 root 5. So as I'm going down, I'm bringing my colors down to show you where I'm getting that from. And if I go further, you will find that I'll be dealing with the square root of 125. This is easy because it's minus the square root of 25 times 5. Now each one over here gave me the next step, as my colors are suggesting. Let's go to the next step. The square root of 16 is 4. So ultimately I have the 6, I don't touch as yet. Square root of 16 times the square root of 5 is the same as 4 root 5. Likewise with this one. The 2 I leave on the outside. The square root of 4 is 2, so this becomes 2 root 5. Minus, and that becomes 5 root 5. This 6 and the 4 is being multiplied. This 2 and this 2 are being multiplied. So the next step should read 6 times 4, which is 24, 24 root 5, plus 2 times 2 is 4. So this becomes 4 root 5 minus 5 root 5. And that, guys, is the same as saying 24 apples plus 4 apples minus 5 apples gives me the value of 23 apples. Very, very good. Guys, this is a good example for the examinations. Example number 2. Example number 2 has appeared in the previous exam papers. Approximately 4, if not 5 marks. Now something like this we would be able to understand, and you would be able to accomplish this. Now, do not worry about the large numbers that you're using, about the division that you are using. Simply work with it step by step. And if I have to work with step by step, 2 root 27. I'm skipping here. 27 is the same as the square root of 9 times 3. That's very good, guys. The square root of 27 is the same as 9 times 3. Let's try to look in terms of this example what I'm talking about. I'm saying the square root of 27 over here is the same as the square root of 9 times 3. And that's where I get the square root of 3 root 3. 3 multiplied by that 2 is where I got the 6 from. If I have to look at the value 108, now you understood where I got the 108 from. It's going to be, yes, 36 times 3, which is the same as 6 root 3. No changes. The square root of 75, as I had done before, guys, the square root of 75 is the square root of 25 times 3. And that gives me the 5 root 3. 3 root 12, the 12. Just one more time, guys. Remember the 12 is the square root of 4 times 3, which is 2 root 3. 3 times 2 is equal to 6. So end up with an answer there of 6 root 3. If I go further, 6 root 3 minus 6 root 3 falls away. I end up with 5 root 3 over 6 root 3. 5 root 3 over 6 root 3. All that happens over here is the root 3 cancels off with the root 3. And you're left here with an answer of 5 over 6. I'll leave you to ponder about that one a moment, guys. It's a simple example. Do not get lost with this one. Let's take it step by step. Example number 3. Similar to example number 2. If we work with this, the answer. Now one more time, guys. 2 root 20, remember, square root of 20 is the same as 4 times 5. I'm saying that is the same as that. Right. 6 root 80. 80, let me start with different colors just for those of you that are still battling about here. Remember, we are saying right, 6 root 80. 6 root 80 is the same as 6 times 16 times 5. Because 16 times 5 gives me a value of 80. The square root of 16 is 4. Remember that. 125 is 25 times 5 over the square root of 5. Very good. If I have to go further, remember the square root of 4 is equal to 2. So 2 times 2 is equal to 4. It's 4 root 5. The square root of 16, let me in fact do this second part for you. Then you'll be able to see exactly what I am talking about again. Now we are simply saying, in this example over here, this is the portion I want to look at. In this example over here, yellow. Yellow is not a very, very good color to use. In color, let's choose a color. What color do you choose? You want black, or purple, or blue. Let's choose blue. Blue seems to be a nice color. All right. In this example over here, what we are saying is, I have the 6 on the outside. Inside here, I have the square root of 16 times the square root of 5, which is the same now as square root of 16 times 5, which we're saying is the same as 6 multiplied by the square root of 16 is 4. The square root of 5 I cannot deal with. I leave it as that. 6 times 4 is equal to 24, and I end up here with 24 root 5. And that's exactly where I'm ending up with the 24 root 5 from here. Minus 25 root 5 is the same as 5 root 5 over root 5. Now, no way cancel that with that. That is not even English. let alone being maths. If we have to go further, I will ask you 4 bananas plus 24 bananas minus 5 bananas divided by 1 banana. That's the same as 23 bananas over a banana, and now I can distinctly see that something is going to cancel off. And when you cancel, guys, let's cancel. Neat one. That cancels with that. Alright, don't go. That's cancelling, but a bit too much. Alright, but just for say, that's a bit too much. In any case, you end up with an answer of 23. Guys, a good example. I need for you to understand this example. There's no getting out of working an example of this caliber. That was just a joke. He came out one way or the other. Okay, guys, activity 3. Simplify the following. Alright, go ahead, guys. Make my day. Question number 1. You can start copying them down as well. Question number 2. Number 3. Number 4. And these guys are examination type examples. If you are able to get these correct, guaranteed, you are going to get the one in your examinations correct. Example number 8. Example number 9. And example number 10. Take your time. Copy them down. Once you copy them down, guys, either press pause or take some time off to do the activity. Once you have completed the activity, come back, look at the answer section, iron out any problems that you might be experiencing. If you encounter any more problems, please rewind to the part where you would find you would require the assistance. Watch it over again and again and again until such time that you get it correct. Press pause if need be. We are now going to go over to the answer section. Press pause now. Number 1. Guys, did you get this correct? Let's go to my point options, my pen. I like a nice color. While you're looking at that, color is red. Right, number 1, guys. Number 1. Come on, guys. Let's go. Numerator, correct, over 4 root 5. Square root of 80 is the same as 4 root 5. Simplify the numerator, simplify the denominator. Cancels, cancels. You're left with an answer of 7 over 4. Did you get 7 over 4? Very good. Example number 2, guys. The square root of 32 is 4 root 2. The square root of 50, 5 root 2. The square root of 18, 3 root 2, all over root 2. Numerator, denominator, cancels, cancels. You're left with an answer there of 2. Example number 3. Now I'm not going to waste too much time. You have attempted this. Correct. Remember, cancels, cancels. 10 over 8 is the same as 1 and 1 over 4. Number 4. Come on, guys. How many of you got the answer 1? Number 4. The answer is equal to 1. Cancels, cancels, cancel, cancel. Your answer is equal to 1. Not to waste too much time, that's the answer for number 5. Again, I'm going over the answer section. If you are experiencing problems, press pause, interrogate the example, understand the examples, and then we can move further. Number 6, you should be getting an answer of 5 divided by 6. Guys, number 7, the answer is 0. Number 8, the answer is 5 over 6. How many of you have so far got 8 out of 8? Put your hands up. Put both hands up. Okay, guys, put your hands down now. You're starting to look ridiculous. Number 9. The answer for number 9 is 0. And last but not least, number 10. Number 10 is a very, very difficult examination question. The square root of 72 is 6 root 2. The square root of 8 is 2 root 2. Watch the brackets. We simplified and we worked with the brackets. We multiplied the bracket out. You are left with root 2 over minus root 2. Cancels, cancels. You're left with an answer there of minus 1. How are we doing, guys? At this present moment, are you this or are you this? I hope we are moving towards that. Now, guys, what I want for you to do is, after this, the next section that we are going to be dealing with will be dealing with surds, but the rationalization of surd denominators. So once you fully understand this concept, go to topic 1, still on numbers, pick on the section where we deal with rationalization of a denominator. Once again, I thank you and good luck.